Your first task was to fill in the rest of the code of this for loop down here. So the first thing that we changed is the wood density. The new wood density is going to be equal to the old wood density minus the time step times the burn rate. Since remember, the burn rate is really just the time derivative of the wood density. Now for the change in temperature. Of course, we start with the initial temperature, and then we add to it h times a bunch of stuff. Now all of this code is just taking into account those 4 factors that we were saying influence the change in temperature. So the first thing we have right here, you can see, is the 2D heat equation. And this is actually implemented using the finite difference scheme. After this, we also take into account heat loss, and then the wind, and then also the combustion. Now going up to the top of our wildfire function, let's talk about this initial distribution of wood density. This first line right here is just a translation of that mathematical expression I had written out for you. The y-intercept of the point that we're considering is just equal to some y value minus the slope that we're given times x. And actually, this xy is the xy that we're talking about at this moment. That means that the wood density then is equal to wood value 1. I have a bunch of typos. Well, that's a problem. Let's fix that right now. See, everyone makes mistakes. This should be wood 2. This should be wood 1. Okay, now that all of that is fixed, we have that the wood density at our point, xy, is equal to wood 1, the maximum possible wood density, plus all of this. This is the difference between wood 2 and wood 1, so that range in which W is allowed to vary across the terrain, divided by the difference between the intercepts. So you remember on the graph that I showed you earlier, this graph right here actually, that is the slope of this line. Since wood density here is on the y-axis and the intercept is actually on the x-axis, if we take the difference in wood density divided by the difference in intercept, we get the slope of this pink line right here. So now you can see that we have the slope of that pink line times the intercept of the line that the point we're considering is on, minus intercept 1. So this is really just using point slope form to calculate W. Remember, we only want W to range between wood 1 and wood 2, so this line restricts it to that range. Now let's look at the plot we get. So finally, a graph of our forest. In both images, we're looking at the xy square of terrain that we've been talking about. But here we're graphing the temperature, shown by these different colors, and here we're graphing the density of wood. Now, unfortunately, this is only a 50 by 50 pixel image. If we wanted to see what was happening with much better resolution, we should use 200 by 200. Unfortunately, my computer is not cooperating, so we're going to have to settle for this less perfect image. Even though this isn't really a perfect picture, you can still tell that the wood has been depleted in the center. The density of wood is very low right here compared to the rest of the area where the fire hasn't spread yet. You can also see that, as we wanted, the density of the wood does vary along lines like this. In the 200 by 200 image, you would be able to see that the wood had been very depleted in the center, and that the fire had marched out to the rim of this area. We can kind of tell that. There's sort of a red circle around here. However, we'd be able to see better that the fire is moving slower and it's less hot in the area where there is less wood. The spreading of the fire is way too slow in this image, and one reason for that is that the heat is averaged over larger pixels, so we're actually not letting the temperature reach the temperature of ignition in a lot of places. I hope you found talking about wildfires as exciting as I have. Awesome job on this problem and throughout the entire course. I hope you're excited for the final exam. I think it'll give you a great look at a ton of different examples, not just from the material we've learned about, but also from some new kinds of applications.